Would you trust an agent which is giving you that output in a life-saving situation?
What if the engineers are the folks coming up with the models? They're the ones who are checking that a programmer can spawn up an agent swarm effectively and safely.
I don't think I buy that. If code is being outputted that will be deployed in life-saving ways, that code has to get a secondary review.
Welcome back to the Pre-Train Pod. My name is Rich, AI researcher in the Bay Area. With me as always is...
Hey everybody, Pierce Freeman. I'm an AI founder, also based in San Francisco, where I've built and sold multiple AI startups.
We're both in San Francisco, in the flesh.
No
dude.
longer
Still feels
AIs.
good. Still feels good. So
I know.
it hasn't sunk in yet, that I live here now.
Yeah.
Still feels like I'm
When do you think
visiting.
it will?
Like in 5 years, probably.
Okay, I feel that.
Yeah, I think it's like as soon as we find our place, then it's real. It's like now we've signed a lease, but for now it's still a little temporary.
Yeah.
But
agreed.
hey man, slow and steady. I got a Vespa,
That's huge.
which is huge.
We should take it for a
dude.
spin.
Oh my God, I love this Vespa. You know what no one tells you about Vespas? Vespas give you full, and this is true, full diplomatic immunity. You can do whatever you want.
Yeah, anything.
Like you can park anywhere. No one cares.
No one's
it's,
gonna check
it's
you.
incredible.
It's a
no
bike.
one's going to check you.
Yeah.
It is literally.
Would I
it's-
ticket a bike? No, of course not.
No, of
It
course.
doesn't have a license.
It doesn't have a license, dude. Well, I guess like it does.
You have a
technically.
license. Yeah,
Technically,
yeah,
it has a
yeah.
license, but it's insane, dude.
Let me tell you, I had to go to the DMV for an in-person license renewal. So I go to the Marin branch because it's less heavily trafficked than the one in San Francisco. And I sit down. I mean, I will say, dude, just our touch points with government in this country are so bad. I feel like the ways we actually interact with the government day to day are when the roads aren't fixed, they're like potholes, the DMV and the IRS. And the IRS people obviously hate. And then the DMV, you go there and it's just sad.
It's just sad.
It's just really, it
It's
doesn't have any
tough.
Wi-Fi. I don't want to be the narc, but it's these pull-up seats that feel like
and then they
they're
have
from,
the
middle
TV.
school.
You know, the TV
Yes,
that's always
yes.
running some B grade ad
For the DMV.
for the DMV.
Yeah.
Exactly.
It's you could at least show sports or something.
What about, hear me out, dude? Bauhaus DMV.
Yeah, I mean, amazing.
We need designers
Yeah.
in the US government.
I actually think we do. We need people with aesthetic taste.
We can talk about this later, but you see the Trump RX thing?
No. What is
So
it?
Trump has this website
For the
buying
medicine.
for the medicine.
Yes. Yeah.
Weirdly aesthetic
Interesting.
website. Are you seeing this?
Yeah, this is nice.
It's
This is objectively pretty nice.
what happened?
It hijacks the scroll, which I don't like.
Yeah, you hate that.
I really don't like that. But the rest of it's quite nice.
If you go on nationaldesignstudio.gov, it says modernizing government experience through design and engineering by executive order, which is hilarious because
it's kind of a bit.
That's
we
kinda
didn't
like-
have a choice.
it's kind of like my vibe as president would be my first order is that everything has to be vibey.
totally. Yeah, totally.
Increase vibes.
Increase vibes. Vibes go up.
Anyway,
Yeah.
you know what else
Claude
has a
doesn't
good
have
design?
license.
No, we're not even talking about Claude. Okay, I'm gonna monologue a little bit if
Yeah,
you will,
please.
if you will
Yeah.
allow it. Okay,
Can I chirp?
You can chirp, dude. Chirp, please chirp. I wrote down some thoughts because I have this thesis I want to talk to you about. Okay, which is that we're living in a new generation of UX experience. In 2 weeks, for $20,000, 16 agents built a 100,000 line C compiler from scratch. All right, it compiles Linux, it
Okay.
plays Doom. You might have heard of this famously, right? Meanwhile, other teams have used agents to build full-on web browsers with basically no intervention at all by humans, right? And then last week, I don't know if we were both living under a rock. We haven't really talked about this recently, but Anthropic and OpenAI just released new models, right? And these ship the infrastructure that makes it possible to build these massive products like the C compiler and the browser from scratch with almost no intervention, right? So here's what's interesting, right? I feel like what we've recently seen is that it's not just that models are getting smarter, it's that as of maybe 2 months ago, there's this paradigm shift in how people interact with AI models as a whole. And that is that agents seem to not only be everywhere, it now seems like agents have their own agents. Okay.
It's agents all the way down.
It's agents all the way down. So that was the introduction. Here's my thesis. Okay.
I'm ready.
The way I see it, Pierce, is that there's been 3 generations of AI tooling user experiences since the dawn of ChatGPT. The first generation, I'm calling this the chat interface generation, okay? Was roughly from 2022 to roughly like 2024. And that was basically like you're interacting with a chatbot. You ask it a question like, write me a function that XYZ. It returns to you some code, you copy, paste it, and then you iterate, right? So that's the chat interface era. The second era, okay, in this Eras tour, is generation 2, the single agent era. And that was 2024 to 2025 last year, which is like Cloud Code, Cursor, blah, blah, blah. You have like persistent context over your entire code base or over whatever thing you're working on. This agent can read files, write files, create unit tests, run the unit tests. And there's like this like multi-step kind of like execution chain, right? But you basically like supervise it. So like the mental model here is like AI as a pair programmer.
Yeah.
As of like the last 2 months, dude, it's been like the dawn of a new generation, I think, right? Generation 3, which I'm calling the agent swarm generation. And that is multiple independent agents. All these agents are running in parallel. There's communication between the agents. Oftentimes there'll be like a meta agent orchestrating everything. And you as a coder, as a human supervisor, all you're doing is you basically provide the infrastructure and the architecture for these agents to start working and interacting with each other. But you're kind of like McKinsey coming in, setting up like an org chart, and then your agents create everything else, right? The AI model is basically the whole engineering team in this case. So my question to you here is, first of all, do you buy it? Do you buy this like 3 generations of AI user experiences? And I guess at what point does this stop being like AI assisted development when we're coding and become like a fundamentally different thing? Like if this agent swarm generation truly is the next frontier, are we still developing code in an AI assisted way? Or is this almost like a completely different type of activity? Can we even call this coding anymore if we're under this new dawn of an era where agents swarm and create code through like an orchestrated, super complicated process?
Yeah, totally. I mean, it's such a good question. I feel like, and who knows, obviously, so just like rampant speculation. The thought exercise that I was doing as you were asking that question, though, is thinking at the extremes of if you got latency to 0, would this agent swarm paradigm still be useful, right? Because we were talking in the last episode about Kimi 2.5 and how it does support agent swarms, at least in this like sub-delegation form. And it does, which is fantastic. And they're claiming it's up to like a 4x speed increase over just doing everything in one conversation for a host of, hardware things. And also just in general in CS, if you can get things to be parallel versus synchronous, it'll speed up. If you get latency to 0, there's an argument which is like, oh, maybe this agent swarm is just like a hack. It's like a shortcut so we can get this parallelism because token generation speeds right now are still relatively slow. Like at the fast hardware, Cerebrus, it's probably 1,500 tokens a second. Sounds like it's speedy, but also you're doing that over a ton of different contexts. You're doing a ton of file changes. You use that up pretty quickly and it doesn't feel like it's instant. Like snap a finger, it happens. If you were to really get that to 0, would you still need these agent swarms? And I think my answer is actually maybe yes in some ways, because I think what we're starting to see a little bit is that all of these agents have the same weights behind the model, right? Like you train one version of Claude, you train one version of OpenAI's model. And then once you have that trained model, the only way that we get it to express different behavior is in the prompt that we give it, right? And like I almost think of modern models, especially with how big they are and the fact that we're using a mixture of experts' heads, is you're almost training thousands of small models that are just wrapped in one really big model, right? And the way that we choose which of the small models we want to use is by injecting the prompt. So if you're able to give things a different prompt, it's actually possible that the model will have totally different behaviors and like maybe express some latent capabilities that would not be possible if you didn't have this kind of specialization up front. And I think what's kind of cool about this agent swarm paradigm is you're basically saying, okay, well, what if we kind of modeled this agent swarm like human organizations where we're like, there's a CEO and then there's a VP of product, VP of Eng, VP of design.
Right.
And then under them, there are yet more people because
sub-agents.
Because back-end engineers tend to be a specialty and front-end engineers tend to be a specialty. And I'll be honest with you, to me, that feels like bullshit. That seems like something that would be nice to have.
Well, like
these,
the organizational structure of
Yeah,
these agents?
basically.
Yeah.
Because I'm like, these aren't people, you know? And I think we're trying to like slot agents in one-to-one with people in a way that they're just not really meant to be, because they are fundamentally different things. Like, these things aren't people. If you kind of squint, there like definitely is something that is different and interesting about this idea, even without having to personify these models, of if you give them regions of ownership that are discrete from one another and you say, focus on these things, don't focus on any of these other things. It maybe is a situation where like the whole is greater than the sum of its parts, where you end up being able to do much crazier and intricate things than if you just had one agent running in a loop, even if it did have zero latency, infinite context window.
Yeah, because right now it's being branded as a latency thing, right?
Totally.
Yeah. So like Kimmy's whole pitch is like, being able to orchestrate agents in this way makes them all much faster. But I think you're right that it's not just that, it's like the user experience also fundamentally changes as a programmer, right? It's like once you start having to think about how these different agents talk to each other, it's almost like how when you're coding and you're coding up like a very parallel program, it's a much harder task because you have to be careful about the parallelism bugs that can come up. It's almost like the same way with these agents, where you have to be really careful when you're constructing these like orchestrated agent models, that the models are communicating in the right way and are doing really parallel tasks. Otherwise, there could be like some kind of like weird interference between these different agents. I guess like my point is that once you start working with orchestrated agents, the user experience of you like actually coding, like vibe coding, is like totally different. And even like in the last 5 years, like what it means to vibe code has already shifted so much. I remember when we started with chat, I don't know about you, but I was like literally copy pasting stuff from ChatGPT right into my IDE.
And even before that, or like contemporary with it, you had Copilot.
Right, exactly.
From GitHub channeled through VS Code, which was like an autocomplete of maybe the next line.
Yeah, exactly. And you would like use these two things kind of like in parallel. You know what I mean? And that was the user experience of using these tools to develop code. Then we got Cursor. And now all of a sudden, like not just is the tab autocomplete better, but you have this side pane where you can now interact with the model in the code, and it can like start, working on your code, looking through your files, making bigger changes. I think like from a user experience perspective, that is like a pretty fundamental like design shift. And I think we've all like successfully adopted this new paradigm pretty well.
Yeah, it's like these different axes of things are happening concurrently, which is hard to miss. We both have development of the software tooling, like the user interface, which is literally the GUI that you're interacting with, is getting more sophisticated and tailored to its agents. You can even see how Cursor in the first generation was just that sidebar to the right. And now there's that wholly separate Cursor interface that lets you just kick off the jobs and have it modify code. And then you also concurrently have this evolution maybe of how the agents are working behind the scenes, where I think at the limit, the agent swarm is kind of an implementation detail. It's like if it gets you the same result, which is modified files on disk, it almost doesn't matter how exactly it's doing that behind the scenes. So I think both things are happening at the same time. I do think maybe it's worth double clicking though on these two different ways that you can have agent swarms. You can either have them as one centralized executor that's delegating and then aggregating, maybe more of this like map reduce, like fan out, fan in paradigm. Or you can actually have these like task workers that are all separate and can freely talk to one another. Do you want to talk a little bit more about that?
Well, yeah, because I actually want to disagree with what you just said. I think like actually like the design implementation detail here is very important with these agent swarms. If you look at Claude Code, they have documentation for how you should set up your agent swarm. And they have like a best practice. And they're pretty like clear and candid about what they think is the best practice for this, which is that you should basically set up an orchestrator node, kind of like a team leader is what they call it in their docs. And the team leader should have access to these like delegated task-specific subagents. And that these subagents should be able to access skills, and skills here being basically just like additional prompts that you write into a folder on your device. And the subagents can then access those skills by looking into like this folder that you provide, and can search basically like what skills they should use at every time step. So in effect, what like Anthropic is saying here is, hey man, like when you're working with agents, think about this as a different user experience design paradigm. Don't just type in your request. Also add skills that you want your subagents to have, and think carefully about how the orchestrator talks to different subagents. Like that communication, that like scaffolding of how the orchestrator interacts with different agents is now basically part of the requirements of the coder, of the human, basically, to set that up. And I feel like that's kind of a radical design shift that I myself haven't like internalized what that really means. Like I haven't really used this at all. But I think it's like a thing that in the next year, everyone is going to have to come to terms with. Like it's a different way of interacting with these models. It's kind of like how it now feels antiquated to copy paste things from a chat window into your IDE. In the future, it's going to be like, I can't believe we actually just would write a request in this like cursor side pane
without like adding any additional plumbing.
Without adding the plumbing. That's crazy that we just expected these models to know what to do. And so it's interesting. Yeah, I mean, Anthropic is being like pretty opinionated here about how you should be using this new paradigm. And as said, like they have this, I think everyone should read the docs because I think they're pretty interesting. And it's interesting from their docs to see like how they envision folks using these models, because the reality is often that people don't follow the spec and will come up with like some other paradigm, you know what I mean, for how to use this stuff. But yeah, the way that they want you to do it is like they want you to have skills. They want you to have connectors, which are basically like these MCP, these model context protocol things that let your agents interact with like things like Slack or Google Workspaces, like third-party tooling. And then your subagents are the specialized agents that get called on by this like orchestrator node. And then you as a programmer can also use these things called slash commands, which invoke like certain actions. So you can be like, when an agent wants to make a request for, I don't know, information, go to slash like information : get information. And then that will basically invoke that action basically as its output. Does that make sense?
Yeah.
Yeah. So it's like,
I think a lot of this stuff has been supported in Claude Code for some time now, where like this was part of the convention or the scaffolding that you could do. There are also hooks that are involved in that too.
Exactly.
And they all come from this Claude Code synchronous world. And now you're seeing it just extended to this multi-agent case.
Yeah, because they're saying like, if you're going to try to develop something like a compiler, like a C compiler like they did, hypothetically, you're going to need thousands of agents performing these tasks. At that point, you can't just have them like nilly-willy kind of just do things in parallel. You need to be really explicit about what things each agent should be working on, how they basically coordinate amongst themselves, and what sorts of like outside skills that they can access.
Yeah. So I think that's totally right. And there are two different ways of thinking about this, right? Because the option number one, and I think it doesn't help that these both have kind of been collapsed under this agent swarm umbrella, is like route number one is basically saying, I'm going to have Claude choose its own swarm, which is kind of what it does when it launches these sub agents. I think this might have been rolled out like 1 or 2 releases ago.
But I feel like that's the wrong approach, right? That's not what you're supposed to do.
It's a different paradigm. To me, they actually are compatible but different, right? Where like one is just purely this parallelization play, which is the former. And then this one is like, you actually can get more complicated emergent behavior by having swarms with particular roles. So like the first one, which is this sub-agent specific thing, I think is specifically like Claude is choosing what to do, which again, I think useful for parallelism. Maybe we disagree on that. And then the second case, which I think is a really interesting one, is like, let's invest this time up front to actually assign roles and responsibilities. And instead of sub-agents, which are usually spawned and then torn down once they're done, it's kind of like this team lead, if you want to think about it, owns all the ground truth of information. In this agent swarm model, instead what you have is the context windows of the individual agents that are launched themselves are long running. So it's kind of the equivalent of, if we're on this team, I'm an agent, you're an agent. I can send you something and say, okay, now I know that I've notified Richard about this. Richard can do some processing, do some thinking for hours, come back to me with something else, and then that is added to my context history so I can have both in parallel. And that's like a pretty useful paradigm. It's almost like using...
It's more advanced than the first one you explained.
Way more advanced.
Yeah, it's like that
You're like combining memory with these action possibilities. And you could even like use an agent as like just a memory agent, like some scratch space that you just send stuff to. It's a really interesting model.
It's like this brave new world right now, man, where it's like these sub-agents have opened up this brand new paradigm for how to perform computations. And it's hard to slot that into any existing paradigm that I have for how compute works. Is the right way to think about these orchestration of like agents and like team leads and sub-agents as like a new version of a classic computer science like multiprocessing, where you'll have, if you're writing code, you can have like a set of tasks and then you can spawn like 10 different programs in parallel to incrementally make progress on this task by splitting it up into small chunks, and each of the processes working on a small chunk in parallel, or like the threat pool approach. Or is like the right way to think about this a version of an event loop like we have in JavaScript, where it's not necessarily in parallel, but what you're orchestrating is basically like sets of different tasks, and there's a certain optimal order in which to tackle these things. And then you as a programmer can say, well, I want you basically to figure out what that optimal order is and how to do that. Is it like that kind of like a paradigm? Or is it just like something different? Is this like a new design paradigm for like processes and threads that doesn't really exist in how we normally think about computer science?
I mean, I think it's a more direct relation to the thread pool of it all than probably to the asynchronous run loop. I mean, there's overlap, obviously, with both of them, but I think that there's this notion of like in a run loop, it's really one thing that's running that can just have interrupts that happen at a specific time. I think that would probably be just making tool calls in this world where it's like you still have one chain of history, you're still following this linear program, or maybe sub-agents, where like you call this function, it does some work, but then spawns back to you and you can take control over from there. Most, but not all event loop programs are kind of architected like that, where you've kind of got this like main runner, which is your coordinator, and then it's just calling things ad hoc, but it's always yielding back to that thing. This is like, I think, more of a task pool, or maybe honestly more like interprocess communication, where you have these things running and you can have message passing back and forth. But I think the unique thing about the message passing, actually maybe why IPC is a better construct here, is because once you've sent something, you know that it's delivered, but number one, you don't really know how the other system is going to process it.
Mm-hmm.
And then similarly, I can't access your memory. Like I can't reach in and then tweak things about how you're seeing the world or what you're processing, or even really like knowing what you're doing without a message arriving to me to tell me what's up. So they're
like stateless in that way, I guess.
Exactly.
Right.
Yeah. It lends itself to like a pretty interesting mode of like,
but in this case, they could be accessing each other's memory, right? With the agents.
Maybe. I mean, again, if like we've set up a paradigm where like I can send you a message to like ask you for some state, and then you can send it back to me,
right.
Or maybe we're both writing to some centralized cache. I think really what this does is this blows open the door in a pretty meaningful way of the possible complexity of these overall orchestration systems in a way that, one, is very exciting. And I think, two, practically speaking, it kind of explodes the possibility space when you're actually doing RLHF, where if we want to like fine tune models to be really, really good at this stuff, I mean, the complexities of this system when you have all of these things beeping around and sending different messages to one another is pretty staggering. And I actually think that that's probably an active area of research for these big companies of how do we train systems to do this?
And RLHF being here like using RL to copy how humans would process these tasks?
No, more just like the GRPO phase.
Oh, like the post-training phase, you're saying?
Exactly.
Okay,
of trying to
gotcha.
actually train these models to operate in this synthetic environment
Oh,
where it's
totally.
allowed to do the message passing.
Yeah.
Because thus far, it's been such a strong assumption in this data set that's been generated of like, it's going to be one agent, it's going to follow instructions, make these tool calls. Like, again, this just explodes the possibilities.
Oh, 100%.
So
yeah.
it's possible that our existing models will do fine enough with these agents form tasks just by being trained in this conventional tool call space, because that's all that they're doing. Like these message passing that we're doing is basically just a tool call with like some destination and some message. But at the extreme, if you really want to make an agent swarm model that's quite good at doing this, it does kind of feel like you're going to have to boot up specific RL environments that are just calibrated to this kind of task. And scoring that becomes that much harder too.
In what way? Like the evaluation task?
The evaluation task of like whose model do I give credit for what kind of data input? You know what I mean?
Because you want to basically reward the model to have spawned a certain type of structure of agents, right? Because it solved the task maybe faster with that structure.
Totally.
Yeah.
But at the same time, if like my agent pool is working and has 30 different agents that are all working in concert, how do I back prop those weights? Like if you give me one valuable piece of information and some agent uses that later in the chain, do you get partial credit for that? Was that a good learning policy
Yeah,
that you
totally.
have had?
I mean, this is
it all
a
on me?
classic problem of reinforcement learning.
Definitely. But I
Like
think
the-
it gets way trickier
reward
once you
attribution.
have the
Yeah.
same model duplicated n times. You know what I mean? That's a new construct.
Okay, well, what about this? I kind of feel like the trend in computer science is to have things be as modular as possible. And like, could you see there being a world in which at the limit, we find out that these agent swarms are very successful, and we end up with a world in which, you know, rather than a computer having like 64 CPUs or 128 CPUs or whatever, we start thinking about a computational engine as how many swarms of agents it can support. You know what I
Mhm.
mean? Because like if compute changes where at some point we're not coding anymore, maybe the only thing that really then matters is how many agents can we basically spawn in our cluster? And does each agent become almost like a computational unit of this brand new type of computing, you know? Where the orchestrator, like the guy at the very top who orchestrates this whole thing, is kind of like the operating system. And you can talk to the operating system, you can interact with the orchestrator. And then the orchestrator, like your computer, like once you've interacted with the operating system, it can then choose basically how many CPUs, in this case, agents to spawn up and in what order to spin them up. Do you think that's plausible? Or is that kind of like this sort of like romanticization of this process, like maybe wrong? Like,
Are you saying like literally taken to the extreme of screw Mac OS X, screw Windows, we're having a fully new operating input interface? Or you're saying just this is maybe a way to rethink about computing in terms of these like different core primitives than CPU and logical instructions?
if coding eventually becomes more of a computation, maybe like at the experience of the coder is what I'm talking about. So like if coding
Mhm.
becomes you interacting with this orchestrator that is a long living process that basically becomes your way to access the operating system. And us as coders then don't really have to know anything about Bash or Tmux or whatever, right? The only thing that we know is how to talk with this orchestrator, just like we currently know how to talk with
Python and not
Python?
assembly, maybe?
Yeah, exactly. None of us really know what's happening at the level of the kernel of our computers, even as coders, right? The computer has like different layers of abstraction that we understand. Like most folks that just interact with the computer just look at like the graphical user interface. If you're a coder, you can go one level deeper and you can interact with, you know, like scripting languages that let you then basically interact with the compute of your computer in like a pure sense, where you can actually access the CPUs in like a pure sense. And maybe that's the future paradigm of coding. It's like you interact with the orchestrator, which gives you like this low level access, but the orchestrator then can go very deep and like actually figure out how to spawn these agents, which then in this paradigm become like the CPUs of your computer. I don't know. Does any of that make any sense to you? I know I sometimes can get very like sci-fi with these things, but I do feel like the fact that we've had the same experience with a computer for the last 25 years, I think is going to be disrupted, I think,
Mhm.
within our lifetimes. You know what I mean? And like thinking about whether or not these agents are a new design paradigm, I think is actually like pretty important.
Yeah, I mean, I really do wonder at some level, like, which of this is an app versus like which of these is a core primitive that's baked into the OS as a whole. But I think it would be fantastic if your construct with your computer is like a unit to do work versus a unit to enjoy things can be as high level as possible. You know what I mean? I think for a long time, we kind of thought, hey, maybe these no code, low code interfaces could fill a really big gap here. Retool is this one company that was really popular for a while. And now I think because so many things have become agentic and like code first has fallen off a little bit in terms of companies' adoption. But like it was basically this idea that we always recycle the same building blocks for building web interfaces when we're trying to build internal apps. So we need some database shim, we need some graphs, and they have like, you know, a bunch of these different puzzle places. And you can drag them into the UI and say, here's the data source that you should connect to. Here's maybe some transformation. This is visualization. This is a button, yada, yada, yada,
Yeah.
right? And that was like very useful while it lasted because it was a way of saying like, can we do things at a higher level that's consolidated and central, but don't require us to like do additional work in the plumbing
Yeah.
behind the scenes, right? And I think what we're seeing now is a little bit like that actually was probably just an interstitial in the extreme of where we're going, which is if you can have something that's more bespoke and perfect for your purposes, people usually prefer to do that versus having to work around these limitations of these puzzle pieces. Like instead of having to work with puzzle pieces, it's way easier to draw, or at least it's way more extendable to be able to draw. And that's what we're talking about here. Like we're talking about just drawing from a blank canvas and making whatever you want. To this agent swarm question, I kind of still see it as a way to mostly get out this emergent property of being able to poke and prod at different experts that are internal within the whole model. We're like, if what we're doing with writing out this markdown file of what is the job role that you should inhabit or what is the skill that you should acquire, we're basically talking concretely about writing a markdown file that gives it some instructions and then lets it execute upon that. And if you go into the Claude skills repository that they have online that's utilized by Cowork and whatever else, that's all that it is, right? It's like a collection of markdown files. It's like some tools that are purpose built to be more useful for, finance or law or whatever, which are Python scripts basically by themselves. So it's markdown and it's code. And those combined kind of create those skills. I think the useful thing, like technically that I can really ground myself in from like a research POV is we're getting different weight activations by virtue of these markdown files that we're giving these models. And by virtue of that, we're getting different property from like agent 1 to agent 2 to agent 3 to agent 4. So I think there's like something really useful there. I think to the question of like, does this level up to a whole new compute paradigm that involves us maybe not even looking at the code that's outputted by these pipelines? And I think a lot of that comes down to just like the accuracy and the sense of self-confidence and like calibrated confidence that the models have. Where if you're looking at an organization, right? If I'm talking to the VP of some department, I'm pretty sure, first off, I have an existing relationship with them that like indicates.
If you're the CEO, you're saying.
If I'm the CEO, or really if I'm anybody.
Sure.
But yeah, sure. If I'm the CEO, I'm talking to my VP and I'm like, Mark, you're overseeing all of product. I'm probably going to trust Mark's take, both because I hired him and I know that Mark's in like continuous conversation with his team and Mark is checking their work. It's like he's in design reviews with the design team. And if they put out something that's not up to the company's bar, he's going to call them out on that. And I've seen him do it. And I'm like, I know you're good at doing this. And, humans are consistent enough over time and have personalities that if he's done that I've observed, I'm probably going to trust him
with Mark, sure.
for the N+1. You know what I mean? So I think like a lot of the crux of what level of this stack, if this is kind of modeled like a corporate org from like top down, what order of the stack do I feel comfortable interacting with? Is it the VP layer or is it the level of an individual designer? A lot of that to me comes down to the consistency of these orchestrators to be able to give me verifiably correct work long enough that I mostly trust what they're going to say and that they themselves have nitpicked before it gets to me.
This is great. I think, this is like a second design paradigm other than the classic CS design paradigm. I think this is a second way of seeing this. And I would actually say that in response to you, I think this is like even a better design paradigm maybe to use as a metaphor for what's going on here. Because if you're the CEO, right, and you're interacting with like the metaphorical Mark here, which is the orchestrator, I suppose, right?
Mm-hmm.
You as the CEO have appointed Mark to be the VP, but usually your job as the CEO is not just to appoint Mark and Mark does all the job. You basically set up the scaffolding for the whole company so that, you appoint Mark, but you also basically have decided, hey, I'm going to have a flat org, right? Where I'm going to have maybe like 10 VPs and they're each going to have 5 direct reports. And the design team, because it's maybe so important to my company, is going to have an extra additional hierarchical structure, right? And a lot of work goes into like thinking about like at the level of org charts, like how to optimally set up personnel and employees to have the optimal, company structure to have the most throughput. So I think that this is actually a great case where you trust Mark because I think not only do you think that Mark is a good person, you also trust that the organizational structure of your company will let Mark have the right answers, right? Like a lot of MBAs and like McKinsey folks get hired to set up these organizational structures so that the VPs have maximal oversight over their employees and so that they can have the optimal sort of like ability to intervene in their companies, right? Like it would be useless if Mark, as the head of product or the VP of tech, didn't have the ability to talk to the folks who work on the back end of the product, right? That would be a bad structure.
And actually, if I can just say one additional thing, which is in the McKinsey structure of things, the formal reporting structure is different from the actual things that form day to day because people build relationships. And even if you're interacting with someone at another team very frequently, you're probably going to develop an individual rapport where you're in effect message passing between yourselves, right? Because that is the emergent property of a better organization. If anything, in agent swarms, it's actually more intense because when you're curating these possible proposed relationships, you actually can enforce those deterministically within code. If you say, Mark should literally never talk to the head of finance, you can make that happen in a way digitally that in reality you would never have.
Would be impossible.
Yeah, totally. Because it's like you're working in the same office. If you see the CFO, you can go to his office and talk to him. You know what I mean? Or like if she's on Slack, you can like go on Slack. It's just, it's a very different paradigm, I think, when you think of these agents and like you forcing them into structures that doesn't quite map to reality, but makes it that much more important to think about these structures that you set up from the offset versus are learned over time.
Yeah, 100%. But I do wonder to what extent that's going to matter in the future. You know what I mean? If it is true that this agent swarm paradigm is going to take off, I wonder whether future CS students will have to learn like what is the optimal way to set up these agents. Maybe in like a way that kind of parallels human organizational structure. Is that something that we'll even have to consider?
Yeah. Is that like 210?
Like I remember,
in the future?
Yeah, maybe. I remember when I was studying like management sciences during undergrad, we would do all these case studies, right? To look at like, hey, how does like Kraft set up their organizational structure, right? How does the National Forest Service set up their organizational structure? And there's a lot of research into like how companies optimally allocate personnel to different departments, whether you want a flat or a vertical structure, whether you want like matrix organizations where there's like cross-functional teams and stuff like this, right? There's a ton of folks that work on this stuff and there's like a lot of research into this. Clearly, like this has some big impact in the real world. I wonder if that's going to be a thing for agents as well, whether like it matters that you have one orchestrator node that has access to 3 direct reports who then have access to 3, you know what I mean? Like, is there going to be like any like secret sauce that people develop, for how to optimally structure these things? Or is the future that agents will just like automatically learn to structure themselves?
I mean, I've got to think that at the point where we're talking about being able to do this reliably and at scale, an orchestrator is going to be good enough to suggest to you what the optimal organizational dynamic is, much like how a VP probably has a point of view about what their own structure should be within the whole organization. I think it's just like a level of sophistication that if and I think it's a big if you're able to reach with these agent orchestration systems, you're kind of building in some notion of organizational dynamics that maybe even you're training into the models when you're building them from scratch. And I imagine that that's probably able to be extracted from the model or informs the model's input that it can give you that then helps you structure it. So I don't know about necessarily like a changing CS paradigm in schools. I think we already see CS curriculums evolving their stance on this a little bit where like, I think if you ask most CS teachers, they're not immune to the fact that AI is everywhere in industry. Like these are very well-connected people. A lot of them, honestly, at Stanford have even started AI companies. So like they know how these things work in the real world, which is, you walk into a co-working space right now in San Francisco, and there are way more Claude Code windows open than there are people typing on their keyboard into Vim or into VS Code or Cursor or Zed, People are using these agents and like that's how increasingly software engineering works. And in universities, you still see profs for the most part teaching the core algorithms, teaching the core, design paradigms, core system structures. Because at the end of the day, code is going to be written by someone or something. And I think the thinking up until now has been humans are at least going to review what this work is that's outputted by these systems because the code is the ground truth. Like the code is actually what's going to run. And I think for me, I still would like a human sanity checking that until these models get so good that they are as good or better than the average person.
I think what we're going to need is for these models to be really good at explaining their own behavior in a way that allows us to have the ability to say, oh, like I really buy that this model understands what it's doing.
Exactly. They need to be reliable. They need to have calibrated self-confidence. Let me ask you something though, Richard, because I think in the abstract, as I was saying that, I was like, oh, if a model is really good, like cracked engineer status, PhD from Harvey Mudd, would I trust this model to be able
I don't think they do PhDs, right?
Oh, they don't?
I think it's just
the
undergrad.
Claremont thing? Okay.
I don't know. Maybe.
Well, never mind. Carnegie Mellon PhD.
Yeah.
Cambridge PhD, perhaps. And it gets you back some result. On some level, I'm inclined to trust that result is probably right. If, however, this was software that was used in a life-saving instrument, like you're working for Varian Medical Systems or some like biotech company, where if you get this wrong, if you ship a bug, like people will die, right? Are you ever going to trust an agent that doesn't have a corporeal form? Because the check on a lot of things in society is if you do something that is negligent and knowingly negligent, you personally will go to jail. You can't hide behind some organization. It's like you are liable. And I kind of think that's a good thing, like it raises the stakes of people sanity checking their own work. If you build a bridge and it falls down, you're liable. Like that, I think adds a good structure to things when maybe people are otherwise inclined or like incentivized financially to cut corners. Would you trust an agent which is giving you that output in a life-saving situation? Or are you always going to want to review some code?
I mean, I would say that currently, no, right? I think I would always want to currently check my code. But
I would say ever. The extrema is like ever.
But it's one of these things where once you get used to a complicated system, at some level, there's an understanding that the system is so necessary that, look, it might be super complicated, but we just need this system to work. And we need this system in order for like a functioning society. So we'll take the risk of you not being able to check all of it fully all the time. Here's a good example. Maybe airplanes might be a good example, right?
Okay, sure.
So it's like, look, man, are airplanes safe? Sure. Can airplanes mess up? Of course, right? Airplanes get mechanical errors all the time. Would we say, hey, pilots, like before every single flight, you have the lives of 200 people in your hands. Would you ever fly this plane without making sure that every single instrument in the plane works? I think they'd say, yeah, we just can't check every instrument on this plane. There's 100,000 little computers running on these planes. There's no way we could check that before every single flight. But look, guys, like these things are safe enough. 1 out of every 100,000 times there's a problem. And, only 1 out of every billion times does that problem result in an actual accident. And these things are just so important to the world commerce that we just can't envision a world in which we don't use these. Right?
So I actually think this is a perfect metaphor because it draws this delineation between using agents in the wild and agent swarms in the wild and using them to write software. Because I actually think in the plane case, I actually do expect that the people who are engineering the plane check each part. Like I think that's a reasonable expectation. It's like if you're building and architecting the schematics for a new plane, like you have done your due diligence. And if there is something that was found to be negligent in either the sourcing of these parts or the manufacturing of the plane, like you're individually held liable. The pilots aren't, but like the engineers are.
So that's writing the code, you're saying.
So that's writing the code.
What if it's this? I think we're converging. What if the engineers are the folks coming up with the models? It's Anthropic coming out with this agent swarm model. They're the ones who are checking, hey, have we pre-trained this so that the agent swarm spawns correctly, does the right actions so that the orchestrator can talk to the agents correctly, so that a user like a programmer can spawn up an agent swarm effectively and safely. And then the programmer are the pilots. And then I don't know what the agents would be in this metaphor. But isn't that?
I don't think I buy that. I think because in my mind, if code is auditable, which it is, then I think the onus has to be on a person. Again, like in this life or death case, if you're vibe coding some software, it probably doesn't really matter. But if you're really doing something that's like life and death, I think regardless of how the sausage gets made, if it's like a model, if it's a person, or it's like whatever, there has to be like some gating function to just be a sanity check or a series of sanity checks.
Why can't that be built in by the Anthropic engineers into the model?
Because Well, are you going to hold those engineers liable for what their agent swarm does when it's deployed by someone else? Probably not. They're not shipping the variant system.
Let's go back to the airplane example. I think this is perfect. Okay.
Yeah.
So look, like Boeing, when they create their plane, they run through all these tests. They get, FAA approval. They make sure all the parts are clean, blah, 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 blah. Right.
But Boeing in this case would be the medical system company. I'm arguing, not Anthropic.
The medical system company?
Yeah. Because you're actually building like the plane.
Oh, I see.
It's not like what's upstream of Boeing. Like you're not like auditing Linux for the Linux kernel that Boeing puts in these planes. Linux is the Anthropic here.
Linux is the Anthropic. No. It's Boeing, dude. Because look, I think
Boeing, we might just not agree on this.
I feel like Boeing creates the plane, and they also create all of these safety checks in the plane that automatically occur right before the airplane takes off. The pilots presumably are beep booping, pressing all these different buttons. When they press a button, it's Boeing code that's running, checking to make sure that the engine calibration is correct and that the pressure and blah, 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 right? And then, Boeing basically gives you some set of guarantees. It says, hey, if you run all these checks, we're telling you with a 99.999% certainty that this plane is airworthy, fly it, right? But if you're a pilot here, you can violate some of these checks and then you can be found liable, right? If the plane crashes, you didn't run these checks, you didn't take care of the plane, then that's on you. So the liability kind of like it's conditional in this case, right? On like whether you use the system correctly and respected all the safeguards. So in this case, it's Anthropic as the metaphorical Boeing here creates all these checks to make sure that the model, when a programmer is using it, setting it up, that the model checks itself, has internal checks, has like internal safety mechanisms. The programmer can disregard those. If they do so at the peril of being able to be found liable for the model swarms having some bad activity, right? Causing some harms in the world. But if they run it, kind of like rid themselves of the liability, and in which case, if things go askew, it falls back on Boeing, right? For not having been rigorous enough in their testing and their, safety harness.
Yeah, dude. I think it's super interesting to be like, where do you actually draw the line here? I think I still come down pretty strongly on if code is being outputted as part of this pipeline, that itself is being incorporated into devices that will be deployed in life-saving ways or life-costing ways, that code has to get a secondary review. And I think like some of that is just a question of practicality. Like I don't think Anthropic possibly can calibrate an agent swarm to have all of these safety checks and guards in a way that's generic enough that would be able to supersede what, I keep using Varian in this example. It's basically just like this med tech provider in Palo Alto. It's like this big one next to Stanford. But, any medical devices company, like the industry knowledge they have about the failure modes, the specific if-then sequencing that they know this system needs in the wild, like I think they're just kind of the only people that are capable of doing this. And then I think like the pilots are the people that are actually using this in a hospital as the medical appliance. You know what I mean? So it's like there's negligence at maybe 3 layers of the stack here. But I guess time will tell, man. Maybe to see like where these. I think we're gonna need some new like laws and probably people who are debating these to be able to draw some parallels to how we've typically regulated engineering prowess and like civil engineering in the past. But yeah, I think I deeply believe that like we need to audit the code. I think we might just differ on that.
Don't get me wrong. I think we have to audit the code.
But you're saying audit the model. I'm saying like audit the output of the model.
I'm saying I think it falls on Anthropic to be able to incorporate some automatic safeguards into the model. Because
I think that's true too.
And look, and I'm saying in the case of the pilot example, like pilots go through a ton of training, right? And I think like engineers in the future, we can't have vibe coded engineers that have grown up vibe coding their whole time. Like at some level, like you need to make sure that folks understand what they're doing. Like we don't throw just like random people into the cockpit of a plane, right? Ideally, the people using these models are highly trained, understand what's going on, right? If it's someone who hasn't gone through the proper training, like they wouldn't be allowed to fly this plane to begin with. So they know what they're doing. They're running all the checks that Boeing has instrumented into the plane, combined with their own, like intuitions about their field of expertise.
Do you think you'll need a co-pilot?
I think I probably.
Like a little pair program.
Not like buddy. Microsoft Copilot, but like an actual
not
Copilot.
Copilot TM. Yeah.
Yeah. I mean, it's hard to think about these things because right now, I would 100% agree with you that like you have to be responsible for your code. Maybe like we're like, maybe the mismatch here is that I'm thinking like 50 years ahead or like 40 years ahead when there's a whole new generation of coders that's being born today that grew up with these models. When they go to college in 20 years, might not have a CS degree in any way that resembles what we have, right? And we're like, yeah, being an engineer just like means something different than it does today. And at that point, I think we do need to have these models with internal safeguards that are running that can self-control and self-identify bad behavior. If you follow the trend of research and you look at what is Anthropic doing, what are companies like Goodfire doing, these like interpretability companies, I think that is going to be a core component of these safeguarding tools, right? Companies that can actually build in tooling that is self-aware and can like spot risks in how it's being used, I think is going to be within like the remit of these companies, right? Like the things that we demand of them.
Mm-hmm.
But I don't know, man. Okay, a third thing that I think is interesting with this new paradigm that we're living in is this like new frontier of adaptive thinking that is now part of the coding paradigm as well. Like all of these models that have come out recently have multiple levels of effort, low, medium, high, and max. And it's interesting because it implies that computing becomes like non-deterministic in this interesting way where you as the coder can sort of specify for a given problem how much computation you think is required. And depending on how much you specify, the output of your model changes, right? And that is like an interesting new paradigm to think about because it's like before when we were spawning processes, all processes kind of like were independent, but like roughly the same. Like if you're creating a thread pool and you're creating n different processes, all of the processes are effectively identical. They just kind of like process different parts of the input. But this is saying like, no, the different independent workers, I as a programmer can dictate how smart each of those should be, right? It's this brand new way of thinking about computation as like constrained or, you know, like where the level of computation can be dictated by the programmer, but not exactly what is being computed.
Mm-hmm.
So I guess like my question is like, how would we even go about building reliable systems on top of, you know, these like non-deterministic computational engines that can adapt their own like resource usage?
I mean, I think we're directionally in the right direction here, quite honestly, because we've started to see most of the major cloud providers actually moving away from having users explicitly tell it the thinking level. Like Claude Code, when it first came out, you could use these keywords that were kind of cheeky. Like you could do think, think a little bit, or ultra think, which was think a ton. And I'm pretty sure everyone at this point, like OpenAI, Anthropic, Mistral, have all deprecated this idea of like user customized thinking tokens, at least for user facing functionality, into this auto world where it just chooses what to think. And like ostensibly that's trained within its actual learning process to try to calibrate, okay, how much do I have to think given how hard this task is? And I think that's actually good empirically because there's some research that came out that showed that if you think too much on too easy of a problem, you can often get the wrong result.
Yeah, we were talking about this.
Yeah, exactly.
Yeah,
you kind of like think in circles. So
yeah.
I actually think that that's like the first building block is getting like pretty good at auto thinking, which minimizes the need for explicit thinking specification a little bit, like makes it a lot more of this adaptive paradigm. But yeah, I mean, TBD, if it's at the level of the question that you're asking to these models or at the level of the message, I guess, or if it's the entire model, you know, like maybe actually in the sub agent, we want it to more emulate a junior programmer, or its main job actually is just to churn out code really quickly. And then some senior will review that with a lot of thinking tokens to see if it's good, maybe even to up level. I mean, this is getting kind of ridiculous, but like, could it up level the agent by maybe like writing some hints into its history of like what it should do differently so it can kind of like explore and maybe level up to like a different paradigm? I'm tempted to say that that's still probably overkill at the current phase that we're at. And you're better off almost always setting things to max thinking tokens, or at least to auto thinking tokens across the board versus artificially setting them low. And instead try to build systems around it that can accept more asynchronous inputs and outputs. Because I mean, the thing that launched this whole hypothetical was like this C compiler. I think that was churning over the course of weeks, right? Or like,
I think it was like 2 weeks.
at least like a week, right?
Yeah.
Which obviously means that we're changing the whole contract that we have instead of, I'm doing something and maybe I'm letting Codex spin for 30 minutes as it tries to solve some meaty problem. And instead I'm saying, let me organize my life. Let me organize my organization around this idea that there's some project that I'm just going to spin out to GPUs instead of people. And it's going to come back to me whenever the job's done. I kind of think when we're talking about that paradigm shift, shifting everything just to be max token utilization and then letting it run for a week and a half versus a week is probably kind of the same thing. Especially if that increases the individual accuracy. Because one thing that we haven't really talked about is whenever you get to systems like this, you can get into a situation where you have compounding errors at different levels of the stack, right?
Right.
Where if you do one little thing that's bad, something else is based on that, it does one additional thing that's bad. Suddenly you have this multiplicative cascade of errors or failures or whatever that end up with the whole thing turning south.
And the problem with that is that it used to be the case that you eventually get a syntax error, right? If you messed up too often.
Yeah.
Nowadays, models are really good at making the code run, even if it's really buggy code.
Totally.
Right.
Totally.
They'll find some way to hard code some fix in that is clearly not what you intended at all. The code will run, but then it'll just be a monstrosity of a zombie kind of monster where it's okay, it kind of technically works, but it's totally useless. And it's actually just using a lot of these resources. It's a complete waste. Right?
It has a try except on everything.
Yeah,
so
it's
never
what
fails.
is this?
Totally.
Exactly.
Yeah. So, I think net, at least at the current stage that we're in, optimizing for minimizing errors and probably optimizing for the maximal tokens that you can to think before it tries to solve something is probably the right way to go.
I think interpretability is going to be so key.
Yeah.
I'm not particularly bullish on mecha as a whole, but I think self-interpretable systems that can elucidate to the programmer what they're thinking about in a way that is actually reliable and that is verifiable. Because the issue is you can ask a model hey, what did you think about? But you have no guarantees that the output of that isn't just slop, right? And that it's actually what it really thought about. If we can make R&D advances into interpretability so that we can have a 99% guarantee that when you ask it, why did you do this or why did you think in this way, it'll give you the answer that it actually maps to its computational process correctly. That'll be huge, right? Because then that'll unlock our ability to say, okay, well, I understand how it thought. If it's not thinking enough, I can force it to think a little bit more. Or it could even do that job itself, right? If the model itself is introspective enough and correctly introspects about its actions, then it should be able to self-determine that it needs more computational power, right? But I think that is going to be an interesting line of research that I think is still really nascent. We've barely tapped into this whole interpretability line of work. A lot of companies like Anthropic, Goodfire, yada, yada, they're all working on interpreting the weights of the model, which is interesting, but it's a little orthogonal to what I'm talking about here.
Totally. Yeah, you're saying client side.
Client side, yeah.
Which makes sense. I mean, people need to be able to audit these histories.
Especially if we're talking to the orchestrator.
Yeah, totally. It's I think chain of thought fundamentally came out of a desire to increase the accuracy of these models, not to increase the interpretability. And I think now we're saying, especially as we have these multiple things going on at the same time, the way it's implemented for Claude Code is actually spinning up TMUX panels. So you'll have all your separate agents just churning at the same time, talking to one another. First off, we need better user interfaces, bar none. And
That's
I'm sure
great.
we will. Those are going to come. It always leads with a TUI and then, eventually gets its own UI. But it also means that some of this stuff that was, again, just accuracy pushing is probably going to have to become user-centric observability. And I don't think a lot of people are working on that right now, but probably will be soon.
I think so too. All right, Pierce, I want to end this conversation by asking you, where's the ceiling with this approach? Are there certain problems that you think can't be solved using this swarm of agents approach? Clearly, the C compiler was interesting because it felt like one of these AlphaGo moments where there was a problem. In the case of AlphaGo, there's this model that solved chess for the first time, right? Or what am I talking about? It solved Go for the first time.
That's right.
What was the chess one called again?
Deep Blue, right?
Yeah, right? Deep Blue. Yeah. This felt like writing a C compiler kind of felt like one of these unattainable problems that all of a sudden we kind of solved, right? So do you still feel like there is a ceiling that we can't break through with this agent swarm approach? Or is this like the thing that is fully scalable
Yeah.
and can get us
Almost
to
anything.
Yeah, it's almost anything.
Yeah, I mean, look, I think consider me dubious still on the C compiler and this browser that was released. I think the browser was Cursor or AnySphere, which is the group behind it, and the C compiler was Anthropic actually doing it itself, because it's seen examples of browsers and C compilers in its initial training corpus somewhere. I think one thing that they did, which was good at inference time for the C compiler, was they limited its ability to search the web. So it was a completely, at least mostly, air gapped, clean room implementation of the C compiler. That still being said, I mean, if you prompt Claude or OpenAI, especially the untrained before instruction tuned versions, like, give me the completion to this prefix, which is, part of a Harry Potter chapter, it will give you that completion.
Sure.
This is like how people kind of probe for copyright violations. So models have a pretty unique ability to both memorize as well as generalize within the same weight space. And I think we still don't have a full handle or grasp on which is which, But I think it's certainly true that it has seen multiple compilers, including probably like the main C compilers in its training corpus that it was trained on that led to the weights that then it was asked to do the C compiler. So to me, what is like the impressive POC here is basically that through delegating and like delegating specifically to all these different models, it was able to build a C compiler that loosely approximated the real thing. Like, I think the ability of models to coordinate with these different context windows is like a non-trivial advancement. And that's what it shows me. It's like, oh, wow, like this is actually possible as an implementation. In terms of like the problems that it's able to solve, I saw some, smarter compiler folks than me actually like auditing the code of this, or like some browser people auditing the browser. And they were like, this like works, but it's horribly written. It's not readable. It would be very like unextendable. It'd be very hard to like piecemeal, like move these things around. And judging things based on the amount of lines of code that's written, like, writing 100,000 lines of code isn't a really good metric.
Yeah, it's almost the wrong
It's
metric.
actually like the worst metric.
You want less lines of code.
Totally. Yeah, totally.
Yeah.
So,
or you want like optimally readable lines of code.
Yes.
Right. Yeah.
You want like a right-sized ratio of lines of code to the complexity of the problem, basically, like fundamentally. And yeah, so to me, these are like good proof points basically around, yes, we can boot up agent swarms. Yes, they can message pass in a way that actually gets us to some outcome, in a way that both makes problems more tractable, as well as like potentially speeds up the implementation of these solutions. In terms of, will this make me throw problems at these coding agents that I didn't before? I think honestly, my answer is no. Like, I think the scope of the problems they're able to do, or like the debugging prowess that they have, my sense is it's still on par with what it was able to do before. It's just like this allows for parallelizability and potentially allows for like just size of projects that you couldn't really throw at it before. But very few people are going to be writing things on the scale of a C compiler.
So you don't think that this is like a major innovation at the level of the tech being used here?
I don't think by itself, no.
Interesting.
Do you have a different take?
I think that when we beat the game of chess, right, with Deep Blue, we said we beat it because it was better than any human at the time, right? Since then, we've developed chess engines that are like astronomically better than Deep Blue, right? So like the thing that was already better than a human is, I think at this point, something like 1,500 times worse than the current best chess engine, which is I think called like stock engine or something like that, right?
You know a good bit about that?
Yeah.
A lot of chess systems actually were benchmarked to the speed of solution.
Oh, interesting.
When you're like choosing the difficulty level, like if you're on an airplane or you're like on your Mac, it gives you an option of like how good do you want the system to be. It's the same exact engine. It's just it was capping how long it spends to think of
like the depth, right?
Exactly. Because it's like, but it was specifically a time-based thing versus a depth thing. And as clock speeds got faster and faster, they didn't update the numbers that were associated with those difficulty levels. So you see on a lot of like personal computers now, the easiest mode is actually near impossible because, a second of thinking time back in like 2005 now can happen in just like an instantaneous 10 milliseconds.
Yeah, exactly.
So these systems are just cracked. It's like the easiest mode on these systems. It's just so freaking hard. Which speaks to your point, like evolution of systems.
Yeah, exactly. The evolution of systems makes something that feels like this is good, impressive, but isn't like astronomically much better than humans, within a couple of decades, be a system that is like unbelievably better than humans, right? So I wonder if like this, your critique of the C compiler is akin to folks looking at Deep Blue back in the day, being like, oh, this is pretty good.
Mhm.
You know what I mean? A single human could never have done this, but it's like, it has its flaws, To now, like when you look at these stock engines, like they have effectively solved the game of chess. Like these things have an ELO score of, I'm looking it up right here. It's almost like 5,000.
Oh my God.
Right. And I think Magnus Carlsen is at what, 3, almost like 3,000.
Yeah.
The different, and every 100 I think is you're like 3 times better. Right. So it's like 3 to the 20th or something. It's something insane, right? It's like, it's more than the number of atoms in the universe better than Magnus Carlsen.
Yeah.
Right?
Wild.
It's like ridiculously good. My point being, like, maybe we'll get a really good C compiler generated by one of these things in the next 15 years.
Yeah.
Yeah. So who knows, man?
I think it's deeply possible.
We'll see, man.
This was such a sci-fi conversation.
I know, man. I love these like shower thought podcasts.
Yeah.
Where it's just what's the future gonna be like?
No, so do I. And also we should add, like, if people want to play around with this themselves, you can on the current version of Claude Code. You just have to enable a preferences flag in order to get this to work. It's not the default behavior. It's still kind of this like research prototype. But go out, play with it. Let us know what you think.
Like, comment, and subscribe.
Well, we will be having some special YouTube exclusives soon.
Oh.
So that actually is a real reason to like and subscribe.
100%.
Or it turns out we're real people. I'm still sick of
You're
getting
a
this
real
argument.
boy.
I'm a real boy. I swear to God. No Pinocchios here. No AI
You
generated
sure you're not a
slop.
little robot, dude? Little Boston Dynamics action going on here.
I don't have nearly the moves. Those things are so coordinated.
You should
dude.
have just like busted out the robot.
I know.
That would've been sick,
dude.
Bleep. All right. Practice the dance,
Okay.
and then we'll like
Yeah,
do the
yeah,
big
yeah,
reveal
yeah.
in a year.
Okay, into it. I'll need that much time. I'll need that much time. Cool, Rich. Any
boss.
any ending notes?
No, I think this was a great combo, dude.
Another week in the life. I wish health to your agent swarm.
You likewise, dude.
Thank you.
Is that going to be the expression of the future?
Maybe.
May you have
make it
a
stick.
successful swarming
That's right.
agent.
That's right.
That's right.
All the best to your swarm.
All the best. All right, buddy.
Okay.
See ya.
Later.
Bye.